today's video, we're going to talk about average rate of change. And I wanted to start out by just simply looking at the definition. This is the full definition of average rate of change. We're going to focus on this formula right here because this is going to be the magical formula that we're going to use to solve our problems. But before we get into that, I want to go back to something more familiar. And this is a line. We probably remember dealing with lines in high school. And one thing that we remember about lines is that if you want to find the slope of a line, you would do rise over run. I'm sure you remember that phrase from high school. And what that means is that, hey, if you pick 2 points on the line and you play this rise over run game, you can find the slope. So if I do rise, 1, 2, 3, and then I do my run, 1, 2, 3, 4, that will go in the denominator, our slope of this line would be 3 over 4. Okay, so the problem is, let's say if we have a curve like this, you can only find the slope of a line. So when you are faced with a curve like the one you see on the screen right now, this is a parabola, you can't find the slope of this line or this curve, okay? You can only find the slope of a line. So what do we do when we have a curve like this? Is we use the average rate of change, okay? What we do is we look at this curve and we say, okay, let me pick a point on this curve, let's say right here, and let me pick another point on this curve, let's say right here, and let me draw a line between those 2 points that I picked. Now, what average rate of change is going to do is it's going to find the slope of that line that you created. Okay, so that's what average rate of change is. So average rate of change, if I find the slope of that line that I just drew on this parabola, it's not the slope of the parabola, it's the average, right? So what we're going to do is I'm going to give you a formula, an equation for a curve, and we're going to find the average rate of change from one point to the next, right? So on this, let's say this is going to be like an A, some value A. And then right here, this is going to be some value B. And if I want the corresponding Y values, they would be right here. This will be F of A. That's the Y value for your A. And then this one right here would be F of B. This will be the Y value for your B. Now, all of these variables and mathematical symbols that you see, those are the same symbols that you see in the definition. You see F of B, F of A, B minus A. That's where all of these things come from. They match up to the actual picture. So how does this work? Now let's get to the nitty-gritty here. So here's an example right here. So this is an example of a curve, right? If you drew this on the XY plane, it would make like a parabola, okay? We're going to find the average rate of change in 3 different areas. The first one is going to be from 3 to 5. So I look at 3 to 5. I'm going to look at 3 as like my A value, and I'm going to look at 5 as like my B value, okay? Now let's make sure we remember the formula. The formula looks like this. F of B minus F of A over B minus A. So let's just fill in the gaps, right? So F of B, my B value is 5, minus F of A, my A value is 3, and then at the bottom I have B minus A, which is 5 minus 3. So I have everything plugged in. Now I need to solve, okay? But I can't solve right now because I have here, I have an F of 5, and here I have an F of 3. I got to actually find those values. So how do you find F of 5? How do you find F of 3? you reflect back to the original problem. F of 5, if I was to say this in English, that means go to the f function and put 5 wherever you see x and then solve. That's what that means. That means go to the original function and wherever you see an x, you're going to put a 5. So in place of the x, I put a 5. Now let me simplify this. What's 5 squared? 25. What's 25 times 2? 50. And what's 50 plus 4? 54. Okay? That's going to be for the first box, right? And I do the same thing with f of 3, right? What does f of 3 mean? F of 3 means go back to the original function, and wherever you see an x, you're going to put a 3. Okay? So that will be 2 times 3 squared plus 4. 3 squared is 9. 9 times 2 is 18. And 18 plus 4 is 22. Okay? So let's rewrite our problem now, right? This is going to be 54 minus 22 over 5 minus 3. Now I can simplify. I have all my numbers there. Now I can look at this and simplify it. 54 minus 22, that's going to be 32 over 5 minus 3, that's 2. And then 32 divided by 2, that's going to be 16. So the average rate of change is going to be 16 for part A. Okay, let's do this again with part B. Negative 1 to 1. Let's do this again with part B. First, I'm going to write the original problem down just to make sure that we remember what it was, because I know sometimes I forget. 2x squared plus 4. And we're trying to go from negative 1 to 1, right? Making sure. So we're trying to find the average rate of change from negative 1 to 1. So negative 1 is like our A. Positive 1 is our B. So let's fill in our original formula here. So let's rewrite this. This will be f of 1 minus f of negative 1 over 1 minus negative 1. Be careful with your signs there, because the formula has a negative sign in it, but you're plugging in a negative number. Okay, so what does f of 1 mean? What does that mean? That means go to the original function, and wherever you see x, you put a 1. Okay, so f of 1 means go to the f function. Wherever I see x, I put a 1. So I'm going to write it down here. I'm going to write the original problem, but I'm going to put a 1 in place of the x, so you can see this fully written out. Minus, what does f of negative 1 mean? That means go to the f function, and wherever you see x, you put negative 1. So I'm going to put the original function, and instead of an x, I'm going to put negative 1. So now let's clean all this stuff up, right? So in the bracket, I have 1 squared, which is 1, and 1 times 2 is 2, and 2 plus 4, that's going to be 6. Okay, minus, over here, I got negative 1 squared, which is 1. 1 times 2 is 2, and 2 plus 4 is 6 again. Okay. And at the bottom, I have 1 plus 1 because the two negatives come together and make positive. So what I end up getting at the top is 6 minus 6, which is 0, and then 1 plus 1 is 2. And what's 0 divided by 2? 0. So the answer for the second part of this is 0. Okay, so I have 16 and now I have 0. So let's look at the third option. It says let's evaluate from -3 to 0. -3 to 0. Let's try this one more time. So the original problem is 2x squared plus 4, and we're going from -3 to 0. We're trying to find the average rate of change from -3 to 0. So our A is going to be -3, our B value is going to be 0. And now let's rewrite our formula so we know exactly what we are trying to do. So f of b, my b value is 0 minus f of -3. And then at the bottom, I have 0 minus -3. Being careful with my negative sign. So f of 0 means go to the original function, and wherever you see x, you put 0. Then f of -3 means go to the original function, and wherever you see x, you put -3. And at the bottom, that's going to end up being 0, 0 plus 3, because the two negatives come together and make it positive. So now let's clean up. 0 squared, that's 0. 0 times 2, that's 0. 0 plus 4, that's 4. Then for the second one, I have -3 squared, that's positive 9. 9 times 2 is 18. And then 18 plus 4, that's 22. And at the bottom, I have 0 plus 3. So 4 minus 22, that's -18 over positive 3. So the answer, the final answer, is -6. So for my 3 answers here, let's scroll back up. I have 16, 0, and -6. Average rate of change. This is a curve, it is a parabola, and we're picking 2 points on that parabola and just finding the slope of the line that goes through those 2 points that you found. And this is your average rate of change. If you have any questions, feel free to contact me.